Hey, everybody. Welcome back from the weekend. We're going to jump into something called conditional statements after our study of inductive reasoning. And remember, inductive reasoning was looking at patterns. And so this is going to lead to some geometry statements. But as you can see in the screen here, are some statements that have almost nothing to do with geometry. We just want to get the hang of how it works. So the first thing is these are both called conditional statements. Maybe I should write that conditional statements. And a lot of times in geometry, what you'll see is conditional statements in called what's if then form. And here's an example of that. If it is raining outside, then there are clouds in the sky. Okay, and so this is in what's called if then form. If then form. Now, in this if then form, the part that comes after the if, immediately after the if, this part right here, if it is raining outside, that's called the hypothesis. And the stuff that comes after the then, there are clouds in the sky. I'm going to underline that twice. That's called the conclusion. And I want you to know what the hypothesis and the conclusion of a conditional statement is, be able to identify it. Now, there's another thing that I want to make sure that we understand, and that's called the truth value. The truth value. I want you to be able to determine is it true or is it false? And if it's false, you can get a counterexample. Okay, so a counterexample is something that you have to come up with if you want to show that a conditional statement is false. Well, let's look at this one right here. If it is raining outside, then there are clouds in the sky. I mean, we can talk about crazy cases and things maybe you read somewhere, but there are going to have to be clouds in the sky. So this conditional statement, if it is rainy, then there are clouds in the sky, we would say is a true conditional statement because we can't come up with a counterexample, a realistic counterexample where it's raining and there are no clouds out there. Let's look at this next conditional statement. It says, on Tuesdays, it is always sunny in Enumclaw. I don't know why I'm stuck on weather. I just am. Well, this is an if-then form. And so one requirement I could make of you is to put it into if-then form. If it is Tuesday in Enumclaw, then it is sunny outside. A lot of times students will find it easier to work with conditional statements if they rewrite them into if-then form. Okay, so again, the hypothesis, it is Tuesday in Enumclaw. Conclusion, it is sunny outside. And notice again, I don't underline the if or the then when I try and identify the hypothesis and the conclusion. Well, let's talk about the truth value of this. If it is Tuesday in Enumclaw, then it is sunny outside. Today happens to be Monday. I'm sure you would agree that there are many, many Tuesdays and probably a few to come here in the near future that it's not sunny outside. So you could get a counterexample by just picking a date. Pick most Tuesdays. Your counterexample could be most Tuesdays in Enumclaw. I'm abbreviating. In the winter, it's not sunny. Or you could come up with a specific date to show that this statement is false by providing this counterexample. Okay, we'll talk more about this and how it pertains to geometry shortly.